Good afternoon, all. We, the physics family of BAM College Thuruthicad, are extremely happy to present to you this webinar, Physics Lab at Away. Now, Dr. Jazima Kurian, respected head of our department, will present the welcome remarks.
Good afternoon, everybody. Though COVID-19 separates us physically, it brings us together virtually in this webinar. In fact, it made us to realize the potential of e-teaching, e-consultation, e-banking, e-commerce, etc. in our everyday life. A small device in our hand, that is, a mobile phone, is sufficient to make us capable for all these e-activities. In online education, we have gone much ahead in e-classroom work for theory courses. However, science students feel a handicap in doing experiments in laboratories. They think that experiments can be performed only in physical laboratories. The concept of virtual lab is a way out for this situation. In fact, MHRD itself have introduced the concept of virtual lab. So it is quite relevant to have an introduction to the virtual lab concept. We have Dr. Noble P. Abraham as the resource person to make us familiar to the virtual lab concept. Dr. Noble is an assistant professor of physics in Marthoma College, Tiruvalla. He is my classmate and a close friend. On behalf of all of us, I extend a warm welcome to Dr. Noor. Our principal, Dr. Biju T. George, is an energy source behind all our programs. Sir, we welcome you to this webinar. I also welcome all the participants, especially teachers and students from various colleges, and our students to this program. Thank you.
I welcome our principal, Dr. Biju T. George, for his remarks.
Respected Head of the Department of Physics, Dr. Jazima Kurian, our Chief Guest and Resource Person of this webinar, Dr. Noble P. Abraham, Shri N. Matthews, Srimati Rajasri S., my dear students of Department of Physics and other participants of this webinar. Firstly, I would like to congratulate Physics Association, students, teachers of Physics Department for conducting a webinar on a very relevant and contemporary issue encountered by science students during the pandemic scenario. During COVID-19 pandemic period, we have transformed our physical classrooms into online classrooms, though this facility is not at all equivalent to physical classes. Our college has initiated a portal for online education, POED, Portal for Online Education, as an online platform for conducting online classes. This facility is led by your teacher, Mr. N. Matthews. The logo of POED is also designed by ENSA. Now our college employs Microsoft Teams online format for conducting regular online classes. This is a licensed online format owned by our college. I think the shortcomings of online classes are much suffered by science students while doing laboratory experiments. There are
the procedure associated with the experiment, the simulations, the other additional resources, a self-evaluation system, and things like that. So a complete learning management system was visualized while MHRD proposed this concept of virtual labs. And the last and the most important objective was to have costly equipments and resources available to everyone, which is otherwise unavailable to many because of time or geographical distances. For example, your college may not be having one of the experiments, say solar cell characteristics. Your college may not be having the equipment to do the analysis, but virtual lab hosts such as setup, and you can do the experiment from your PC. So these four main objectives were in mind while designing the virtual labs. Virtual labs is hosted in the main website. I hope you can all see this site address. vlab.co.in is the address. So this is the main website from where you can reach out all the sub websites where you can see different disciplines or areas of virtual labs available. So here I am showing the different thrust areas that virtual labs has focused so far: electronic, computer science and engineering, electrical engineering, mechanical engineering, chemical engineering, biotechnology and biomedical engineering, civil engineering, physical sciences and chemical sciences. Our interest is, at least in this session, is in physical sciences. So all these experiments are not handled by a single institution. There are a number of institutions, IITs, main institution taking part in this virtual labs is IITs. Share these thrust areas and share different experiments in their website. So if you go to vlab.co.in, you will see the different resources available under these headings. So the participating institutes are IIT Kharagpur, IIT Roorkee, IIT Guwahati, IIT Delhi, IIT Bombay, IIT Kanpur, IIT Hyderabad, Amrita Vishwavidyapeetham, that is in Karunagapalli or Kollam, then IIT Madras, then Dayalbag Educational Institute, National Institute of Technology, Karnataka, then College of Engineering, Puri. You may think that it is mainly for engineering students. Yes, of course, most of the experiments listed under virtual labs is for engineering students, but a good number of experiments are available for arts and science colleges, or mainly the science colleges. I mean the basic science degree students for physics or chemistry or botany or zoology students also can make use of these labs. And all of these institutes will have some or the other experiments for each one of you. Amrita Vishwavidyapeetham is the main resource for physical science. All other institutes will have resources for engineering discipline. Okay, let me show you two main virtual labs websites. First one I would like to show is from IIT Kharagpur. This is the URL for IIT Kharagpur virtual lab. This is the logo. This is the logo of IIT Kharagpur. vlabs.iitkgp.ac.in is the URL. From IIT you can see these many resources for computer science, mechanical engineering, electrical engineering, biotechnology, civil engineering, mining, electronics, chemical engineering and metallurgical, engineering. So let me show you their website. So this is IIT Kharagpur's virtual lab. Phase 2 projects. Phase 1 also have some more resources. I have taken phase 2. So these are the resources available, or they have showcased some of the experiments. So you can see that most of these things are some more advanced. But let me select electronics for the time being. When I have selected, even then you are seeing some of the advanced circuits. Here you can see digital electronic circuits. Here you can see basic electronics. So I will click on that. So I get a new window there. It is showing welcome to basic electronics virtual laboratory. Why I have taken this basic electronics, you will realize when I click the list of experiments. It shows 17 experiments, starting with resistors, capacitors, inductors, Ohm's law, one of the basic laws that we encounter when we start studying physics. Ohm's law, then coming to diodes. When we start studying electronics, the first device that we learn is diode. So the characteristics of diode, you can carry out this experiment. Then as we proceed, we will see half-wave rectification, full-wave rectification, and so on. So let me just open Ohm's law. I will click on that. There I can see these many tabs: theory, procedure, simulation, quiz, assignment, and references. So this is the pattern that most of the virtual lab experiments will have. It will show a theory tab where you can see what are the objectives of the experiments, then what are the principles behind the experiments, and some additional information as well. It will show circuits. It will explain the circuits, and it will explain in many different ways that we very seldom do in our lab. Option to read more into the theory of the experiment. Now I'll switch to the procedure tab. There you can see the procedure to carry out the experiment. This procedure to some extent will show the procedure that you have to do in a real lab and the procedure that you have to do the simulation. Both kinds of procedure you may see. It depends on the experiment. Some of the experiments has to be done a slightly different way than the real lab. So that's why they will show different procedure for real lab as well as simulation labs. So here is the procedure. It will be showing each and every steps how we have to carry out this experiment. And the simulation tab shows many different options. So I will simply click on the Ohm's law option. Okay, let it load. By that time we will, let's see the quiz tab. So it will show quiz. If I click on start, it will show a number of questions. You can answer it, submit, and upon submission you will see. So I am randomly clicking one. Okay, I think I have not rolled here. Okay. is having some error, that's why it is not proceeding. Okay, yeah, you can see when I submit, it is showing a tick mark next to the answer, the choice I have made. Here you can see it is wrong. My answer is wrong. It will show the correct answer, but it will only show that my choice is wrong. See, I got only 2 correct, the rest are wrong. So I can submit it again and again. So till I get the correct answer, and that's the way of that is just another way of learning things. I think the simulation has loaded. So this is the simulation for Ohm's law. Here you can put value of resistance. I will put say that control is not happening. Okay. Okay, here I am changing the DC voltage, and with respect to the change in voltage, I can see the current. Okay, let me see here. I change the voltage from 1, 6, 7, 8 and 9, then the current changes in small units. Okay, so from this relation you can manually calculate the resistance. So you can experiment as you like, but with certain limitations, that you can experiment things. So I will not do the experiment right now, because I have to do another set of experiments. Okay, let me go back to the assignment tab. It will show again a number of questions. Answers are always also given. Then this part you have to do and verify that your answer is correct. And it will show a reference tab as well, references for the theory and procedure and some of the problems. It will show references. This is the basic nature that every virtual lab experiment is having. Okay, I will skip from IIT Kharagpur's virtual lab. I will not go into the other experiments showcased by them, but I will move on to Amrita Vishwavidyapeethams. They have named their virtual lab as Value. I will show their website. They have resources for biotechnology and biomedical engineering, chemical sciences, physical sciences, computer science, mechanical engineering, and cyber security. The URL for the virtual lab is vlab.amrita.edu. Please note the spelling of Amrita, AMRITA.edu. vlab.amrita.edu. Okay, let us see that their website. Since my connection is somewhat slow, it is not showing the images, but this is the main website of Value, Virtual Amrita Laboratories Universal Education. That's how they have named that virtual lab hosted by them. In the home page, they will list the main sections of resources available. From each of these sections, we can choose our set of experiments. So I will proceed to physical sciences. In physical science, I can see different headings, and under each headings I can see different sets of experiments. So the main headings under physical science are electricity and magnetism, heat and thermodynamics, harmonic motion and waves, then modern physics, then laser optics, mechanics, it's a pilot project, then electric circuits virtual lab, again it's a pilot project, advanced mechanics, then optics, then solid state physics, and they will have a online questionnaire for the nodal center, and some of the activities of nodal center is also listed under this heading. So under these many headings, they have showcased around 50 to 60 experiments that we usually do in science departments for core and complementary courses. So I will show 3 experiments. I will not go into the details of physics behind the experiments, but I will show how you can use the experiment. Okay, first one I will choose compound pendulum. So I have opened the window here, but I will show you from where I get this. I have opened from the main website, the physical sciences link. From there I will go down to advanced mechanics virtual lab, and from there you can see compound pendulum symmetric. So this is the resulting page. This is the resulting page. As I have mentioned earlier regarding Ohm's law, this is the detailed theory behind compound pendulum. It will show, most of us are familiar with simple pendulum experiment, but coming to compound pendulum means it is a rigid body that is oscillating. We have to measure periods of oscillations, and we repeat it for 2 or 3 times, and we take oscillations for different lengths, and then we draw a graph, and from the graph that we will estimate the value of g, acceleration due to gravity. So this is how the theory is developed. Here you can see the moment of inertia, that is I0 is equal to mk0 square, and k is known as the radius of gyration. And if we go down, we can see that the moment of inertia of the compound pendulum about the center of mass, and Ig is equal to mkg square. We are familiar with that equation. And coming to the expression for acceleration due to gravity g, we have g is equal to 4 pi square into L by t square. L is the length of the pendulum and t is the period of oscillation. So that is the equation that we are much familiar with, and it will show the procedure. As I have mentioned earlier, it has procedure for real lab and procedure for simulation. So I will not describe the procedure for real lab, we all know, but let me quickly go through. Suppose I have a rod with holes in it, equally spaced most of the time. I will put a knife edge into the hole and make the rod oscillate. I will take time required for say 20 oscillations. From there I will calculate period. Then I will plot that value, the length and the period, on a graph sheet. I will then change the length and again note the period, and do it for many different lengths, as many holes that I am provided with. Then I will draw the graph, complete the graph, and from the graph I will estimate the length of the equivalent simple pendulum, and from there I can calculate g, the acceleration due to gravity. So by studying the theory, I can have a short quiz. I can attend this. Again, let me randomly choose. I am not reading the question or reading the answers. I am just randomly marking some choices, then I will submit. See here. So you can submit as many times you want till you get the correct answer. So by that way you can also learn. Okay, let me switch to the simulator, and this is how the simulator will show you if you do not have an account in the value virtual lab. So you have to click login. Sometimes you can log in with your Google ID or Yahoo ID. The Amrita ID most of you may not have. It is for the Amrita students. But since I am having model center at our college, I have a login ID. So I just logged in. And sometimes you may not see this simulation. So sometimes the Flash plugin is not allowed. Most of the time it is like this, blocked. So you may have to choose allow to run this simulation. If you encounter such a situation, click on the address bar showing not secure. You have to click there and allow the Flash plugin. There you can see the simulation window. If it is enabled, if Flash is enabled, you can show this simulation window. Here you can see the pendulum. You have a timer, stop clock. The length at present is set at 5 centimeters, and this is the advantage of having a virtual lab. You can do it in Earth, Moon, Uranus, Neptune, Jupiter, Venus, Mercury. In different environments you can do. We in a real lab can do only for Earth, because we cannot stand on Venus and do the experiment. But on a virtual lab you can do it even on Venus. Okay, let us not go into the fancy. I am choosing Earth. Here what you do in a real lab, you have to make a small oscillation, a small amplitude oscillation, under which we have the equation G is equal to 4 pi square L by T square. So I will make a very small amplitude and release. So it has started oscillating. The pendulum has started oscillating. So I will note this as the reference point, and from the reference point I will start 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have made 10 oscillations. I have counted 10 oscillations and I have noted the time from the stop clock. Here you can see 14.430 seconds for 10 oscillations. From here I can calculate the time period of oscillation at this length. Okay, I will repeat for 1 or 2 times and I will note down the result. Okay, for 5 centimeter I have taken 10 oscillations and I have got the time period as this. Okay, let me do once more. And the oscillation has not died out, so I will click stop. Oscillation has stopped. Again, oscillation has started. Then I am going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this time I have got a different time, 13.59. Let me put that here, 13.5. So the mean value of t, the time for 10 oscillations, is 14.01 seconds and the time period is 1.401. Okay, this will not give me a correct answer, but let me try. What is the possibilities? I cannot draw a graph. I can only calculate it using L by T square equation, since I have got only one reading. And for sure this answer will not give me the correct answer, 9.8. So to reduce the error that I made in estimating the time for n oscillations, I have to repeat many times, not only for this distance of 5 centimeters from the edge A, but for every possible oscillations. And then I have to draw the graph, and then from there I have to estimate G. So I have to choose another length. So okay, okay.
Please zoom the window a bit more. The screen is not clear.
Okay. Is it okay now? Is it okay now?
Bit more will be fine.
Okay.
Yeah, fine.
Okay. Here I have taken only one length. Now let me choose another length. As in the case of a real lab, we can choose from 5, 10, 15, etc. So I have changed the length. Again I will take oscillation, start the oscillation, and from the reference point I will start counting. After 10 oscillations I have to stop. Then from there I have just stopped, I have not counted, so I have to add another observation. So I will click here the table, and here I can enter for 10 centimeter. Say here I have taken only 6 oscillations. Here I will put 6 point. So there I will do once again. This time the oscillation is somewhat violent because I have made a very quick release, and the amplitude is also very large, so I have to wait for the amplitude to die off. So the amplitude has died down, and I will start counting. Okay, I think I made a mistake, but I will mark that 7.64. So see, the time period is varied. It is because I think I have made a mistake in this value. So what I have to do, I have to redo that part and do for all the possible values of distance from the knife edge and complete the table. and from the table you can have L and T, and you have to draw on your graph paper the curves, and from the curve you have to measure AC BD. It is available in the procedure what length is AC and what length is BD, and from there you have to calculate L, then corresponding to that period you can calculate L by T square, and then you can calculate G. If you substitute values here, let me substitute some random values. It will show L by T square being calculated. So you can verify your calculations by coming to this virtual lab. Okay. By a similar process, you can calculate the moment of inertia as well. So the simulation is simply like this. You can change the length as many that you want in as many steps you want, and you can even choose the environment that you are measuring the acceleration due to gravity. Okay, I hope the procedure is clear. In the zoomed window, it is difficult for me to actually do the experiment, but that's why I have zoomed out a bit. Okay, I hope the experiment is clear. You can simply drag the pendulum and wait for the oscillation to happen in a smooth manner and take the time for n number of oscillations. Let it be 20 or 30 or 40 oscillations that you can count, then stop the count and then enter the data and calculate the text. In some experiments you have this tabular columns available along with the simulation, but in some experiments you will not see such kind of an arrangement. Okay, let me proceed to another experiment. Okay, I will not go into the assignment references tab right now because I have to show you two more experiments. Let me proceed to optics virtual lab, where you can have there are many spectrometer experiments, but I will show you refractive index of a material of the prism. You are familiar with the experiment, I hope. This is the equation. N is equal to sine A plus D by 2 then divided by sine A by 2, where A is the angle of the prism and D is the angle of minimum deviation. So I will not go into the physics part of it, and this is how the procedure is given. As you are all familiar, the spectrometer has to be set correct before we start doing any experiment in the spectrometer. So unless you do the initial adjustments, the simulator will not allow you to carry out the experiment. So what is the first thing? I have to focus a distant object through the telescope. I am adjusting the telescope right now. So this is what we see through the telescope right now. So I am adjusting this pinion adjustment. So you can see something over there. I starting focusing. I can see some kind of a leaf there. Okay, I think it is okay, but it is not very much. Okay, I think this is fine, but see, this start button is not activated. That means I need a further correction. So now the leaves are much more clear. You can see that we are seeing an inverted image. I hope you all know why it is so. Anyway, the telescope is focused. Now I can start experimenting with the spectrometer. Now I can see the spectrometer in full. This area will show what I see looking through the telescope. The collimator is focused to a light source. Here you don't see anything at the moment. I have switched on the light. See here, the light is on now. The light is on now. So I see something over the through the telescope. So I have to focus the slit. I will focus the slit over here. So the control is here. So I am adjusting. Okay, now I get a very clear thin line of the light source here. So this is what is required. Now I think the slit width is okay, but if you think that this slit width is not good for you, you can change the slit width here as well. So for me this slit width is somewhat okay, so I will just use that. So what I have to do next, I have to put prism on the prism table and then make the next step. So now the spectrometer is ready for taking observations. So I will click on place prism. You can see that the prism is put on the prism table with the pointed edge placed correctly. So I have to make observations through its faces for measuring angle. As you all know, for measuring angle, I have to see the image of the slit that you have seen earlier. This image I have to see from its faces, two faces, as reflections. So by placing the prism, I do not see that slit directly over here. So I have to rotate the telescope. I will rotate until I see a reflection of, okay, now I see the reflection of the slit through the telescope. But this is not the correct way of stopping the telescope at the point. So I have to make the telescope crosswire to coincide with the slit. So the slit is now coincided. Now I have to take reading. So here I have controlled the telescope using mouse, but if you want to change using this slider, you can also do that. You want to change the vernier table, you can change this, and fine adjustments. Some of the spectrometers have fine adjustments also. We rarely use those things, but fine adjustments can also be made. And you can change the angle using this sliders as well. And now we are seeing reflection from the first phase, and we have to take observation from vernier 1 and vernier 2. Okay, I will okay. See, this is let me say this is my vernier 1 and this is my vernier 2. From this vernier I can take reading. Here you can see in the bottom part, you can see a zoomed view of the vernier scale. There you can see the vernier scale and the main scale, circular vernier scale, circular main scale and the vernier scale. From there you can take the reading. But before we take readings, we should know what is the least count of the apparatus. By looking at this window, you can estimate least count, and using that you can calculate the reading for phase 1. Okay, now I will proceed to the other phase. I will not go into the details how you complete the table. That part I hope you are all familiar. So this part I will adjust the slider slightly. Now I am controlling the slider via my keyboard. Now the slit is coincided with the crosshair, so I am seeing the reflection through this face. The angle between the earlier observation and this observation will give you 2a, twice the angle of the prism. From there you can calculate the angle of the prism. Now what remains? These steps give you the angle of the prism. Now what you have to see is to change the prism. I mean to observe the angle of minimum deviation. For doing that, you have to change the vernier table. Prism table holds the prism. You have to change the vernier table so as to observe the refracted ray. So I will try to move the prism like this. Sometimes it is difficult to do it using mouse, so I can do it using the slider. So at around say this position, you can see that the collimator allows the light to fall to one of the face, and the light will pass through the prism and it will refract. Let us see if it is visible over here. I may need to adjust. Okay, sorry. I need to adjust the prism in the correct way. Yeah, I get the refracted ray over here. See the top view of the prism. This is how we see in the real lab too. And what we have to do for finding angle of minimum deviation, we have to rotate the vernier table and see that the slip is moving in one side, and as we from the view, we may need to change the telescope too. Now I am changing the vernier table. So now it is away from the field of view in the telescope. Now again I will check the vernier table, and from one position, one angle, you will see that the slit moves in the opposite direction. Slit once stops there and then moves in the opposite direction. There you stop and measure the reading of the vernier 1 and vernier 2. Then you remove the prism and take the direct reading. There you get the angle of minimum deviation. I am going through the steps in a quick fashion. I am only demonstrating how you can handle the spectrometer simulation. I will not do the experiment correctly at this time, because it takes some time to actually see the slit and the minimum deviation position while doing the simulation. You have to control using mouse, so that takes some time. to actually see the angle of minimum deviation position. So I will not go into that part also. And here you can see that there is no tabular columns available, so you have to manually note down your readings and then calculate the angle and then calculate the angle of minimum deviation, and from there you have to estimate the refractive index of the material as sin A plus D by 2 divided by sin A by 2, that familiar equation. So from mechanics to optics, and then I will move on to electronics. That electronics, I have taken characteristics of Zener diode. Here we have a simulator. I will not go into the theory part. I will only show you that simulator, because in electronics most of the people are afraid of making connections, thinking that it will go into some kind of a short circuit. So that's why I have taken this experiment. This is the circuit that we need to construct for drawing the characteristics curve of Zener diode. So let me try to complete the circuit. It is given along the figure. If I zoom in, it will be difficult for me to do, so I will keep this view itself and then try to complete the circuit. Then later on I will show you how and zoomed in view. So I have to connect the battery. See here, I have the battery, then I have a rheostat, then a series resistance, milliammeter, a voltmeter to measure, show input voltage. Then I have the Zener diode, I have a load resistance, and I have to measure the output voltage. So I will start from here. When I drag the cursor over the terminal, it shows a different pointer, mouse pointer, like a hand. So now I have a connection wire with the mouse, so I will try to touch on every possibilities where it matches. I do not know where it fits, so I can drag it and touch every possibilities, then it will connect only the correct point. So even if you do not know how to connect circuits, you can use this. Now I will use the key here for the positive terminal, then I will connect here, then from here I can drag to this point. Okay, it is not happening, so I will do it like this. So even if you are not very confident on how to connect the things, you can just give a try how this is going to happen. Okay, the circuit is almost done, and this will give you the input voltage. So the circuit is done. Since the circuit is done, you will see this insert key active. If the circuit is not done, this button will not be active. So I am inserting the key. This key is inserted now, and the other options are now active. I can choose 3 different Zener diodes with Zener breakdown values 5.6 volt, 7.5 volt or 10 volt. So I will choose the 5.6 volt Zener diode. I will include say a 300 ohm as series resistance. Even if you do not include series resistance in a real lab, it will work. But in this simulation, you have to include the series resistance. It is acting as a protection. so you have to include the series resistance. And you can vary the current, vary the voltage using this slider. You can see the slider is moving. Here I cannot drag the slider here, but I have to use the slider over here. So if I change the slider, I can see that the input voltage is varying. The input voltage is varying, the current is varying. But you see that the load, the output voltage is not varying. Why? Because there is no load connected. So I will connect some load, say 900 ohms. Now there is a voltage. Now if I vary the input voltage, here you can see I am varying the input voltage, the current is varying here, and the output voltage is varying here. So if I keep on varying the voltage, here you see I am increasing the voltage. Input voltage is 5.7, current is 0.34 milliamperes, and the output voltage is 4.27 volts. So I keep on increasing. I see that when I slide the rheostat to the maximum, there is a voltage of 12 volt input voltage. The current is maximum 21.33 milliampere, and the output voltage is. Let me zoom at this point. Okay, I hope it is somewhat visible to you now. If I adjust the rheostat, you can see that even if I keep on increasing the voltage, the output voltage remains at a constant value of 5.6. See here 5.3, 5.59, 5.98, 5.98, 5.99. Then for a very long time it is staying at 5.64. Even if I increase the voltage above the value, it will show this 5.6 output voltage. What is this 5.6? It is the Zener breakdown or the operating voltage of the Zener diode. Okay, these are the three experiments that I wanted to show you this day. I will quickly show you some of the other lab zoom in. Some sample is placed there. You can see there is a magnifier over here, so you can see what sample is put there. From there you can control. See, I can magnify this point by clicking this point. I can magnify all these points, and you may not choose random samples, but the samples that are available to be selected from this, you can place the sample and then see the resulting view, magnified view of the sample that you have put. So I have chosen only one of the experiments for cell biology, and there are a number of experiments available for biotechnology or life science people. There is actually one more experiment for blood grouping. I do not know where it is actually. I think I can choose. Blood grouping experiment is also there, that some can try it out and do how the blood grouping is done. And let me mention that some of the experiments are given like animation mode also. So if I click on start, it will go into full screen and then do the animation part. Okay, now let me show you one of the chemistry experiments. Physical chemistry, organic chemistry, inorganic chemistry, advanced analytical chemistry experiments are there. So let me show you EMF measurement, how to find EMF of a cell. There you have the simulator. If you go through the theory and procedure, you can easily do this simulation experiment. Let me simply drag the temperature, and then I choose a barium electrode, then concentration I can vary, so I can see the voltage over here. I will choose a different anode. I do not see any variation, so I have to choose any kind of questions, or I will show you the presentation again, so that you can note down the URLs correctly. If you have any questions, please do ask. Or is it that you all are in the sleeping mode?
Those who have questions, please use the raise your hand button. There is a question from the YouTube stream.
Okay.
Is there a way to make the simulation easier on a mobile phone?
Okay, let me tell you. Here I haven't actually used this, but some of my students have reported that they can use this Puffin browser, which is more friendly in Android, and in that Puffin browser you can actually do carry out this simulations. This is the Puffin browser from where you can carry out experiments within a mobile phone. Preferably in Android. I do not know what is status in iPhones. In Android, I think at least 20 of my students are doing in Puffin browser. They can actually do the experiment as if we are carrying out this experiment in a laptop. I'm doing in a laptop right now. Laptop or a PC, there is no much difference, but for mobile you have to use this Puffin browser. And one thing that you have to make sure is that you have the flash enabled. If the flash is not enabled, the simulation will not work. Okay, I hope it is clear. Okay, if are there any more questions? Okay, if there are no more questions, let me thank the organizers for giving me a platform to interact with the students, especially on dealing a virtual platform. Many people are aware of such a platform in your colleges. Some of the teachers are also familiar, but people are not very convenient or comfortable in doing the experiment in an easy manner, because maybe they have not given a clear introduction on the topic. So I hope this introduction will help them to actually go in and try your luck in carrying out the experiment successfully. It is actually not very difficult. I tried to make a video first because I thought going live and doing the experiment will be difficult, but I thought let it be. Let me make all the mistakes and let me take all the time and show you the experiments. And that's why I have chosen 3 different experiments, one from the mechanics part, one from the optics part, and one from the electronics part. And the optics part I think is most essential because the spectrometer is a simple device in the lab that most people are afraid of to take any reading or carry out any experiment. So I hope this was useful for all of you. Let me thank the organizers, Professor Ernest Matthews, my good friend, Dr. Jessiama Kurian, my classmate, Dr. Professor Rajasri, and office bearers of the Physics Association at BAM College, Thuruthicad. Thank you all.
Thank you, sir, for the informative presentation. Apart from a few technical glitches, I hope the program was an informative one. And I would like, at the conclusion, I would like to thank our principal, Dr. B.T. George, our HOD, Dr. Jessiama Gurian, and our manager, Abraham J. George sir, for their continuous support. Actually, our manager, Abraham J. George sir, is the head behind all this IT infrastructure we are having. Thank you all the participants for your patience during the technical glitches. We had some initial connectivity integration problems during the program. There is one announcement in the YouTube live chat. We will be posting a link for feedback form, and the e-certificates for the participants will be issued for the participants, those who have submitted the feedback. And the feedback link will be active till 4 p.m. Thank you all. Thank you for the support. Thank you.
Thank you. Thank you.
Very good.